All right, we're going to resume our Unit 2 review. We're going to look at question 3, which would like us to solve this system of inequalities by graphing. This time, my inequalities are not in slope-intercept form, and the first thing I should do is get y alone, because I'm going to have to shade according to my y values, and my symbol could change based on the operations that I perform trying to isolate it. So we'll start with my top function, negative x minus y is greater than 2. I'm going to have to solve for y, so the first thing I'm going to do is add x to both sides, plus x. That's going to go ahead and get the x away from the left-hand side and move it to the right-hand side with that positive 2. Now the next thing I'm going to have to do is get the negative away from the y. That negative is an invisible negative 1, so I can divide both sides by negative 1. When I do that, however, I have to remember the one rule of inequalities that says if I multiply or divide both sides of my function by a negative number, I have to change the direction of my inequality symbol. So I'm dividing by both sides by negative 1. That means my inequality symbol will flip and will face to the right instead of to the left. Now my y is isolated on the left, and on the right-hand side I can simplify by dividing both terms by negative 1. So x divided by negative 1 is negative x, and 2 divided by negative 1 is negative 2. Now I have my slope-intercept form. I can see that my intercept is negative 2. I can graph that. And I can see my slope is this negative in front of x, which is the number negative 1 over an invisible 1. So that means I have to go down 1 to the right 1 to find my next point. So down 1 over 1 for my points here. Now, to draw my line, I have to determine what type of line to use. And this symbol, no matter which direction it faces, the greater than or less than symbol has no equal to portion, which means I'm not going to be using a solid line. I'm going to go ahead and make this a dotted or a dashed line to connect all of these points to show that this is actually an invisible line. Up next, we'll do our shading, and this function says y has to be less than, because we had to change the direction of our inequality symbol. So y has to be less than this line. And that's going to give us all the y values below this line. That's where y is less than. So we'll go ahead and shade below this line. Let's go ahead and follow the same process to solve for y in the second equation and to go ahead and get this graphed. So for my second equation, y minus 2x is greater than 1. To get y alone, I have to add this 2x to both sides. Now this operation will not change my inequality symbol because I'm not multiplying or dividing by a negative. And once I've done this operation, y is isolated, so my inequality symbol is going to be facing the same direction. I have my y-intercept at positive 1, so that's right here on my graph. And my slope is the number 2, which is 2 over an invisible 1, which gives me a rise of 2 and a run of 1 to put my next points in this sequence right here. There we go. Okay, now we can take a look at my symbol. This is a greater than or less than symbol. Either one doesn't have an equal sign, so again, this is going to be dotted lines connecting these points. There's not going to be any solid line because this is an invisible boundary that is not included. There we go. And now we can take a look at the order that we are going to shade. And for this function, our symbol started as greater than, and it stays greater than. Y is larger than this line. So all of my y values are going to happen above the line. So I'm going to shade everything above this green line. And now we can see the portion of overlap right over here in this section of the graph. Here. This is where all of my shading overlaps. So my solution has to take place somewhere in this overlapping portion. Again, I have an infinite number of solutions. I get to pick whichever one I want. It doesn't matter which one I pick as long as it's in this overlapping portion. Now the important thing to remember, again, is that this solution has to be in the overlapping section, and I can't use either one of these dotted lines as an answer. So the place where my dotted lines intersects right here, that is not going to be a viable solution because neither of those lines is included. I have to pick in the shaded portion where both of my lines are included. So the one I picked for my review packet was -1, -8. But anything in this overlapping shaded portion, oh, not -1, -8. I'm sorry. -8, -1. I had a typo. negative 8, negative 1. So right over here in this overlapping portion, right about there. Anything in this shaded portion is acceptable. The final question here is the question, is the ordered pair negative 2, 3 a solution? And as you can see, I've made a very big mess of my graph, but negative 2, 3 is this point right here, negative 2, 3. And I can see that it's in the green shaded portion, but it's not in the yellow shaded portion as well. So even though it solves the bottom equation, it is a solution to this bottom equation, it is not also a solution to the top equation. So the answer would be no. It is not in the portion that is overlapped by both functions. All right, let's go ahead and take a look at question number 4. Question number 4 is moving on, and we're looking at solving using algebraic methods. So question 4 wants us to solve this system of equations using substitution. So we do have to use substitution to solve it because it tells us the method we need to use right there. So let's go ahead and take a look at the steps of substitution. We have to pick a function, solve for a variable, plug that into the other equation so that we can get one of our solutions, and then plug that solution back in to find our other missing answer. So the equation I'm going to pick to solve by substitution is the top one because it's the easiest one to solve for one variable, considering that my top equation already has a variable alone, y equals 3x. I know exactly what y is. So that's step 1 and step 2 already done for me. The next thing I'm going to have to do is take this 3x, the thing I know y is equal to, and plug it into the other function everywhere I see the letter y. So I'm going to rewrite the second function, 5x plus 2 times y equals negative 44, but I'm going to plug in the y value that I have from my top equation, which is 3x, not 2x. Let's try that again, 3x. Now, this is my plug-in step, which means I'm ready to go ahead and solve for the remaining variable in this equation, which is the variable x. So I'm going to try and get them into one spot so I can unwrap them. I'll do that by multiplying the 3x by 2 first. So 5x plus 6x is negative 44. And that tells me that total I have 11 x's on the left equal to negative 44. And I can divide both sides by 11 to finish solving, which tells me x equals negative 4. There's one of my answers. Now to finish, I have to take this and plug it back in to either original function, but the easiest one is the one we chose in step number 2. So y equals 3 times whatever x is, and I know x is the number negative 4 from that equation right there. So y equals 3 times negative 4, so y is going to be the number negative 12. And that tells me that my final answer, if I write it as an ordered pair, has the x value negative 4 and the y value negative 12. And that would be my final answer. Let's go ahead and take a look at question 5. Question 5 wants me to solve the system using elimination, different process. Now for elimination, my first step is to line up all of my variables because I'm trying to turn this into a giant arithmetic problem that I can add up and down, so I have to line up my like terms so that when I add them, everything's ready to go. Now it seems as though my terms are lined up. My x's are above my x's, my y's are above my y's, and my numbers are above each other, but the equal signs are not lined up, and I have to make sure they are. So I can turn these both into x equals problems, or I can move my x and y's to the left like the bottom equation has. It doesn't make any difference which way I reorganize these. I'm going to go ahead and take my top equation and move the 4y over to the left so that these are both in standard form, but again, that does not have to happen in that order as long as everything's lined up. So in order to move that, I'm going to have to subtract that 4y from both sides. So I have x minus 4y equals 1. And my bottom equation can stay exactly the same. X plus 2y equals 13. So now my equations are lined up. Now that they're lined up, I'm going to pick a variable to make the coefficients match. And I'm going to go ahead and pick x for that because both of these x's have an invisible 1 as a coefficient. So they're already matching a number. And that brings me to the third step, which says that the easiest way to combine these is if these signs are opposite signs. Both of my x's right now are positive, which means I'm going to pick one of my functions and change every single sign. It doesn't matter which function I choose, the top one or the bottom one. I'm going to go ahead and choose the bottom one just because I can. So I'm going to change every single letter, x to a negative, 2y to its opposite negative. Now the 13 was positive, so it has to become a negative. Let's make an equal sign. There we go. All right, so I changed all of my terms to the opposite sign, and now my variables x have the same coefficient and opposite signs, and I'm ready to add my functions up and down. So my positive x and my negative x combine to 0, which I need to happen in this elimination step. Negative 4y and negative 2y combine to negative 6y. And after my equal sign, I have 1 minus 13, which is negative 12. Now I have an equation with only y in it, and I can go ahead and solve for y. We're going to do that by dividing both sides by negative 6, which tells me that y is going to be the number positive 2. And again, once I found one of my answers, all I have to do is go ahead and plug it back into one of my original equations. I'm going to plug it into this top equation from the original function because it's an x equals equation, and I think that's the easiest thing to use to find x. So x equals 4 times y plus 1, and I just discovered my y value is the number 2. So let's go ahead and use that to solve for x. X is 8 plus 1, so x is going to be the number 9, which means that my final answer as an ordered pair is 9 for my x value and 2 for my y. All right, we're going to pick up with the next problem in the next video. Review this